The quality report also tells you what percentage of bases has a quality score above 30. So we can see here that in this sequencing run, almost 94% of the bases have a quality score that is at least 30, which means that these bases were called with a confidence of at least 99.9%, which means that these bases have fewer than one sequencing error in 1,000 bases, which is pretty solid. When you go in the report to the section on quality scores, you can see this here. We get overall statistics about the quality of the bases in the reads. So the mean quality of the bases in this run was over 40, which is really okay. We already know that 94% of the bases have a score that is at least 30. And here you can see that 83% of the bases have a score that is at least 40. So this plot shows the quality of the bases. On the x-axis you have the sequencing cycle. So this means that this here represents the first bases in the reads, and this here represents the last base in every read. And for every position in the reads, you get a box plot that shows the distribution of the quality scores for all the bases on that position. So the y-axis are Phred quality scores that represent how confident the base call was. The red line shows the mean value. The blue box contains the middle 50% of the scores. You can hover your mouse over the plot and then you get extra information. You see the mean and the median score and the percentage of bases with a score higher than 30 and a score higher than 40 on that position in the reads. So what you hope to see here is high quality, and you also hope to see that the quality stays high consistently across all the positions in the read. When we look at the slide, you see that I have added blue lines here on the slide, and the blue lines represent the thresholds that AVITI and Illumina use to decide if a base is good quality. So Illumina calls a base good quality if it has a score higher than 30, and okay quality if it has a score higher than 20. AVITI puts the bar higher, so for AVITI, a base is okay when it has a quality higher than 30, and it's good when it has a quality higher than 40. The quality always tends to drop towards the 3' end of the reads, as you can see here also. That's a common pattern. It's almost guaranteed with Illumina data, but it also happens with AVITI data, especially for the reverse reads. So sometimes there is an issue with low quality bases in AVITI data, and it's related to the rolling circle amplification. So if your fragments are much smaller than your read length, it will happen that you not only sequence the fragment, but you also sequence part of the next fragment on the circle. So in single-end data, this will lead to low quality at the 3' end of your reads, so here. In single-end data, this will give rise to low quality at the 3' end of the reads, so here in this region. In paired-end data, you get the same issue, but on top of that, the quality of the reverse reads will also be terrible. So to avoid this issue, the nucleomics score thoroughly checks the distribution of the fragment sizes in your library. And if they notice that the fragments are small, they will choose smaller reads. This is also the reason that in AVITI data, the reads don't go over 300 base pairs. If they would be longer, you would surely have this issue with small fragments. For paired end data, you see separate plots for the forward and for the reverse reads, and the reverse reads are always lower quality than the forward reads. You not only see this on the plot, but you also see it here. So the mean quality is lower for the reverse reads, and also the percentage of bases with a certain quality score is lower in the reverse reads than in the forward reads. It's normal, and it's just because you do 2 sequencing runs. So you do your first sequencing run here, you generate your forward reads, and then you take your flow cell out of the machine, and then you put it back on, and you do a second sequencing run. So of course the quality in this second run will be a bit lower because you have already used all this material and this flow cell for a first sequencing run.